This is SpaceTime, Series 22, Episode 8. Coming up on SpaceTime. Could fast radio bursts be generated by flaring magnetars? Astronomers stunned by an asteroid impact. And the first life has been grown on the moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have developed a new hypothesis to try and explain mysterious cosmic energy blasts known as fast radio bursts. A report in the astrophysical journal Letters suggests that fast radio bursts could be caused by flaring magnetars, which are strongly magnetic neutron stars. Fast radio bursts, or FRBs, are extremely powerful transient blasts of energy, lasting just a few milliseconds. The dispersion signal, that is, the delay of its component frequencies by different amounts of time depending on the wavelength, indicate that these pulses are coming from far beyond our galaxy. Most of the roughly 60 fast radio bursts detected so far have been single events, a sudden powerful blast out of the darkness, and then nothing ever again. However, 2 of these events have repeated blasting over and over again, and this suggests there could be more than just one way to generate a fast radio burst. But as to what actually produces these events, well, that's still a mystery. The authors of this new study, Ben Margalit and Brian Metzger from Columbia University, have proposed that a fast radio burst known as FRB 121102 could have been caused by a young, flaring, highly magnetized neutron star embedded in a decades-old supernova remnant. Neutron stars are the highly compacted, dense stellar cores produced when stars far more massive than the Sun die in spectacular explosions called supernovae. And neutron stars with unusually strong magnetic fields, known as magnetars, can generate extremely powerful flares and bursts early in their lives. Margalit and Metzger argue that these flares could explain the FRB signals being observed. Located in the direction of the northern constellation of Auriga, FRB 121102 was originally detected by the Arecibo radio telescope in Puerto Rico. Then a check of archival data picked up an additional 10 FRBs originating from exactly the same location, and at least a further 6 FRBs have been generated from the same position in the sky since. The burst has been localized to a star-forming dwarf galaxy located about 3 billion light-years from Earth. As well as the repeating FRB, a dim and steady source of radio emission has been detected nearby. The authors suggest that this newly formed magnetar may be resting at the center of a compact magnetized nebula that's trapped behind the expanding shell of supernova ejecta created when the neutron star was born. The magnetized nebula could be powering persistent radio emissions, such as that observed near FRB 121102. The authors also point out that FRB 121102 is emitting from a dwarf galaxy with high star formation rates, and these are known to preferentially host long gamma-ray bursts and superluminous supernovae, which are the exact sorts of events which form magnetars. To test their theory, Margalit and Metzger have developed a detailed time-dependent model of an expanding magnetized electron-ion nebula being inflated by a flaring young magnetar. And their simulations appear to be matching the properties of both the bursting and the persistent radio emission from FRB 121102. I'm Stuart Gary. This is SpaceTime. Astronomers may have just witnessed the collision wreckage left behind by the violent impact of 2 asteroids in the main asteroid belt beyond Mars. The evidence comes in the form of the sudden appearance of a massive comet-like tail stretching out behind the asteroid 6478 Gault. This 400,000-kilometre-long debris trail is greater than the distance between the Earth and the Moon. Astronomers say the debris trail is consistent with 6478 Gault having been in a violent impact with another asteroid of at least half a kilometre in diameter, most likely sometime during October and November last year. 6478 Gault was first discovered by the Mount Palomar Observatory in 1988. It's a spectral type S stony asteroid with a diameter of about 3.7 kilometres, and it's a core member of the Phoenicia asteroid group, a large family consisting of nearly 2,000 known stony asteroids, which formed about 2.2 billion years ago. This group is the highest inclination of all families in the inner asteroid belt, and several of its members are also Mars-crossing asteroids with high eccentricities. 6478 Gault orbits the Sun once every 3.5 Earth years at an average distance between 1.9 and 2.8 times greater than the Earth's orbit around the Sun. I'm Stuart Gary. You're listening to SpaceTime. Scientists have been forced to update the World Magnetic Model because of erratic changes in the Earth's magnetic poles. The World Magnetic Model describes the Earth's magnetic field and is vital for global navigation and communications. While the planet's magnetic poles are constantly moving, that rate of change has started to dramatically increase in recent years, and scientists don't really know why. The planet's magnetic field is generated by a geodynamo, with a molten liquid iron outer core circulating around a solid metallic inner core. But the magnetic field isn't very stable, and the North Magnetic Pole has been steadily moving away from its current position in Canada and towards Siberia, as these deep flows in the Earth's centre change with time. Now, a report in the journal Nature warns that the planet's magnetic poles are moving so quickly that it's forcing scientists to issue a rare update of the World Magnetic Model. The most recent version of the model was published in 2015 and was expected to last at least another year. But scientists say the changes are now so rapid and increasing all the time that it's forcing them to issue an update to prevent serious navigational errors. In 2016, just after the publication of the 2015 model, the European Space Agency swarm satellites tracked part of the magnetic field suddenly accelerating deep under northern South America and the eastern Pacific Ocean. These geomagnetic pulses are thought to be caused by hydromagnetic waves rising from deep in the core. On top of this, the North Magnetic Pole then suddenly began picking up speed as it wandered across the Arctic, from around 15 kilometres per year during the 1990s to a stunning 55 kilometres per year by 2018. Researchers think this could be linked to a high-speed jet of liquid iron beneath Canada. The North Magnetic Pole wandered away from the Canadian mainland and entered the Arctic Ocean in 2001, crossing the international dateline in 2018, and is now heading at breakneck speed towards Siberia. I'm Stuart Gary. This is SpaceTime. China's Chang'e-4 lander has sent back the first images of the first life ever to be grown on the moon. The pictures show a cottonseed sprouting in a miniature biosphere experiment on the lander. Experiment is one of several lunar biosphere experiments being carried out by scientists. The enclosed habitat also contains potatoes, oilseed rape, rockcress seeds, yeast, tomatoes, and fruit fly eggs, as well as air, water, and nutrients, all contained in an artificial self-sustaining environment. Understanding how to grow plants on the lunar surface will help to lay the foundations for establishing a Chinese base on the moon for future exploration and eventual helium-3 mining operations. Helium-3 is rare on Earth but plentiful on the Moon. It's thought to have great potential for use as a fuel in future nuclear fusion power plants. Chang'e-4 became the first spacecraft to land on the far side of the Moon on January the 3rd. It'll measure lunar surface temperatures, analyse the chemical composition of the far side rocks and soil or regolith, study the local effects of cosmic rays, observe the solar corona, and undertake low-frequency radio astronomy research. The lander has sent back panoramic images from the lunar far side surface, and its six-wheeled rover, U-2, is now continuing to explore the surrounding landscape. Meanwhile, Beijing's just announced plans for at least 3 additional lunar missions. The next, Chang'e-5, is expected to launch before the end of the year on a sample return mission. The Moon is tidally locked to the Earth with the same side always facing the Earth. There are great differences in the composition, terrain, structure and age of rocks between the lunar near and far sides. The far side is very mountainous, rugged and thickly dotted with impact craters, giving it a very different appearance to the large, flat, mare-covered near side. About 60% of the near side is covered with mare basalt. In fact, of the 22 lunar mare, 19 are located on the near side. On the other hand, the Moon's far side is covered by lunar highland and anthracite. Scientists don't fully understand the reasons for this geological asymmetry, although they infer that the lunar crust is thicker on the far side than the near side. But as to why that would be the case, it's still a mystery. And this landing will provide scientists with new insights into both the history and formation of the Moon. Because it always faces away from the Earth, the lunar far side is really difficult to study. Landing on the far side places any probe out of direct radio contact with mission managers back on Earth. China's solution involved first placing a communications satellite named Magpie Bridge into a gravitationally stable position in space, known as the Lunar Lagrange 2 position, some 65,000 kilometers above the lunar far side surface. From this position, Magpie Bridge has a direct line of sight with the Earth and the lunar far side, so it can relay communications between the Earth and any far side lunar lander. Once Magpie Bridge was in position, Beijing could launch the Chang'e 4 lunar lander, which they did on December the 7th from the Jiachang Satellite Launch Center in southwestern China's Sichuan province aboard a Long March 3B rocket. Named after the moon goddess in Chinese mythology, Chang'e 4 was originally built as a backup for the 1,200-kilogram Chang'e 3 lunar lander, which touched down in the Bay of Rainbows on the lunar near side back on December the 14th, 2013. You're listening to SpaceTime. I'm Stuart Gary. A new study has found that stellar winds being generated by a newborn star in the Orion Nebula is preventing more new stars from forming nearby. The findings, reported in the journal Nature, are somewhat surprising. That's because until now, many scientists thought that other processes, such as exploding stars called supernovae, were largely responsible for regulating the formation of new stars. The new observation suggests that infant stars generate powerful stellar winds which can blow away the seed material required to form new stars through a process called feedback. The discovery was made by scientists aboard SOFIA, it's NASA's Stratospheric Observatory for Infrared Astronomy, a converted Boeing 747 SP airliner equipped with a large infrared telescope. The Orion Nebula, also known as Messier 42 or simply M42, is a diffuse nebula of gas and dust situated south of Orion's belt in the constellation Orion. It's one of the brightest known nebulae and is visible to the naked eye in the night sky as the fuzzy middle star in Orion's sword. The nebula is located around 1,344 light-years away and is estimated to be some 24 light-years across, with a mass equivalent to more than 2,000 times that of the Sun. It's the nearest large stellar nursery to the Earth, and it's become one of the best observed and most photographed objects in the night sky, helping scientists explore how stars form. A veil of gas and dust makes this nebula extremely beautiful, but it also shrouds the entire process of star birth from view. Fortunately, infrared light can pierce through this cloudy veil, allowing specialized observatories like SOFIA to reveal many of the star formation secrets that would otherwise remain hidden. At the heart of the nebula lies a small group of young, massive and luminous stars. SOFIA has revealed for the first time that the strong stellar winds from the brightest of these baby stars, designated Theta 1 Orionis C, has swept up a large shell of material from the cloud where it formed, sort of like a snowplow clearing a street by pushing the snow to the road's edges. The study's lead author, Cornelia Paps from the University of Leiden in the Netherlands, says Theta 1 Orionis C is responsible for blowing an enormous bubble around the central stars, which disrupts the natal cloud and prevents the birth of additional new stars. SOFIA measured the spectra of ionized carbon. Because of SOFIA's airborne location, flying above some 99% of the water vapor in Earth's atmosphere which blocks out infrared light, researchers were able to study the physical properties of the star's stellar wind. Astronomers used the spectral signature of the ionized carbon to determine the speed of the gas across the nebula and to study the interactions between massive stars and the clouds where they're born. They found the signal to be so strong that it reveals crucial details and nuances of the stellar nurseries that would otherwise have been hidden. At the center of the Orion Nebula, the stellar wind from Theta 1 Orionis C forms a bubble and disrupts star birth in its neighborhood. At the same time, it's pushing molecular gas and dust to the edges of the bubble, in the process creating new regions of dense material where future stars can form. These feedback effects are regulating the physical conditions of the nebula. They're influencing star formation activity and ultimately are driving the evolution of the interstellar medium, that is, the space between the stars filled with gas and dust. Understanding how star formation interacts with the interstellar medium is key to understanding the origins of the stars we see today and those which might form in the future. I'm Stuart Gary. This is SpaceTime. A SpaceX Dragon cargo ship has successfully carried out the first nighttime splashdown, returning to Earth from the International Space Station. The Dragon safely hit the water in the North Pacific Ocean, 300 kilometers off the coast of Baja California, Mexico. This was the second flight for the CRS-16 capsule, which had previously flown on the CRS-10 mission in early 2017. CRS-16 was launched aboard a Falcon 9 rocket from the Cape Canaveral Air Force Station in Florida on December the 5th, carrying some 2,500 kilograms of supplies and equipment for the crew aboard the International Space Station. It was grabbed by the space station's Canadarm3 and successfully docked with the orbiting outpost's Harmony module 2 days later. The return to Earth came after several days of delays due to bad weather in the splashdown zone.
Station Robo, release is commanded.
Copy, release commanded.
Station Robo, snares are open. Begin monitoring for drift out.
Station's monitoring. Robo station observes good drift out.
Robo copies, good drift out.
Robo station, the pin has exited the lee. Go for back away.
Robo copies, pin has exited the lee. We're proceeding to back off.
Pin.
Station Robo, back off is in progress.
Station copies. Pins 1 meter.
Copy, 1 meter.
0.5.
Copy, 1.5 meters. We are going course.
Meters. 3 meters.
Copy.
4 meters. Station's continuing with step 4.
Go for step 4.
And station, the VV mode is departure. Dragon depart commanded.
And Houston copies, we see it. And Station Houston on 2, departure burn 1 is complete. Departure burn 2 in approximately 1 minute. Monitor per step 5 in 1.602.
And station copies.
SSRMS back away complete. Station Houston on 2, departure burn 2 is complete. Departure burn 3 in approximately 7 minutes. Monitor for step 6 in 1.602.
And station copies.
And Station Houston on Space to Ground 2, departure burn 3 is complete. Dragon is outside the keep-out sphere.
Houston, station copies.
The Dragon was carrying some 1,800 kilograms of return science experiments. The capsule was safely recovered and loaded aboard a recovery vessel after its 6-hour journey from the space station. The recovery ship then sailed back to the port of Los Angeles, where time-sensitive experiments were quickly unloaded and handed over to NASA, while the rest of the cargo will be unloaded at SpaceX's test facility in McGregor, Texas. SpaceX's next space station mission is expected to be the first unpiloted Demo 1 test flight of the new Dragon 2 crew capsule, slated for February for a 2-week stay. The unmanned maiden flight will test both ground and space flight systems associated with the new spacecraft, which is expected to be carrying its first astronauts to the space station by mid-year. The Demo 1 or DM1 test flight will fly aboard a Falcon 9 rocket from Pad 39A at the Kennedy Space Center in Florida. That's the same launch pad used by Apollo 11 on its historic mission to land on the Moon 50 years ago. If all goes to plan, NASA expects the first operational Dragon 2 crew mission, carrying up to 7 crew to the space station, to occur sometime around December. Meanwhile, SpaceX competitor Boeing are planning their first unmanned orbital test flight of their space station crew transfer vehicle, the CST-100 Starliner, to take place around March, with the first manned test flight slated for August. Since the mothballing of the Space Shuttle program in 2011, the Russian Soyuz capsule has been the only means of getting astronauts to and from the space station. And that exclusivity saw a sudden tripling of ticket prices by Moscow, from around $20 million up to over $60 million per seat. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have managed to grow perfect human blood vessels called organoids in a petri dish for the first time. The breakthrough bioengineering technology reported in the journal Nature dramatically advances research in vascular diseases such as diabetes, identifying a key pathway to potentially prevent changes to blood vessels, a major cause of death and morbidity among those with diabetes. An organoid is a three-dimensional structure grown from stem cells that mimics an organ and can be used to study aspects of that organ in a petri dish. This could potentially allow researchers to unravel the causes and treatments for a variety of vascular diseases, including Alzheimer's, cardiovascular disease, wound healing problems, stroke, cancer, and of course diabetes. Iran says it's going to increase its nuclear enrichment from the 3.67% agreed to under its existing nuclear non-proliferation treaty up to 20%, an important step in any clandestine weapons-grade uranium enrichment project. Tehran points out that 20% enrichment is still well below the 90% needed for weapons-grade uranium. The announcement follows the latest acceleration in Tehran's efforts to develop long-range intercontinental ballistic missiles under the guise of a space program. Iran's nuclear and missile programs are closely based on North Korean technology under a technology-sharing agreement with Pyongyang. North Korea used the cover of a space program to develop its long-range nuclear missile technology. Intelligence agencies warn that Tehran is doing the same thing, but that's a claim rejected by the oil-rich nation, which insists its nuclear program is for peaceful power generation only. Bad news, everyone. A new study has shown that Big Brother can gather behavioural data on you by examining as few as 8 or 9 of your contacts, completely throwing away all that work you've done to try and be anonymous online. A report in the journal Nature Human Behavior has found that machine learning algorithms can pick up the activities and interests of an individual by their social ties with 95% accuracy. Further proof that you really can know a person by their friends. And if all that's not enough to terrify you, it seems deleting your accounts or even not having one in the first place can't guarantee privacy. A separate study in the journal Nature Human Behavior has shown that your choice of music on Spotify can provide an insight into how you're feeling or how you might want to feel, where you're from, how old you are, and even what time of day you're listening. The study examined 765 million online music plays, streamed by 1 million individuals across 51 countries. It found that younger people tend to listen to more intense music, Latin Americans listen to more arousing music, and Asians listen to more relaxing music. Researchers also found that more upbeat music consumption patterns occurred during the day compared to more calming sounds at night, all of which only proves that you can't put me in a box. The scientific method involves observation, hypothesis, experimentation, analysis, and conclusion. Science is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim. See if it's factual and stands up, or if it's just a great steaming pile of woo. That's what skepticism is all about, a search for the truth. And remember, scientific facts don't care if you like them or not. In Australia, the federal government and health insurance companies have decided to exclude so-called natural health therapies, including things like aromatherapy and homeopathy, from the list of medical treatment rebates. Now, that doesn't stop you from using them. It simply means they won't be covered by health insurance. They've been excluded because there is simply no peer-reviewed scientific evidence that they work. So imagine our surprise when a report appeared on the Channel 10 Evening News claiming patients may suffer because of the changes preventing them from getting rebates for practices that don't really actually work. It again raises the question of whether poor journalism is supporting quack medical practices. Tim Mendham is from Australian Skeptics.
This is the long-standing government policy, which they brought in some time ago, announcing that certain, quote, natural, unquote, therapies would no longer be covered by the health insurance general treatment subsidy. As we know, the federal government that gives a subsidy to people to take out private insurance, and they're saying that, well, these things we're no longer going to cover. So basically, the private insurance companies are saying they have to seriously consider if they're going to cover it at their own expense or not. But I think in some cases they probably won't. This includes such things as aromatherapy, herbalism, homeopathy, iridology, kinesiology, naturopathy, all the ologies, actually reflexology, a whole range of things.
This means I can't get a refund for crystals?
Yeah, sorry about that. We did a survey many years ago of insurance companies looking at what they covered, and there's only one private health insurance company that did not cover all of these sort of strange, unproven therapies.
That was the one the doctors used.
Exactly, the doctor's one, yeah, which you couldn't belong to unless you were a doctor or a nurse.
And that must tell you something about what real medical practitioners think about these natural medicines, as they're called.
Absolutely.
What does it say about a journalist, but who describes the resulting cut of natural medicine funding as possibly affecting people's health?
Honestly, I don't think anyone's health is going to be hurt by not doing these things because they don't do nothing. It will help their pocket, though, actually.
It also says a lot about how little people understand about how natural medicine simply don't work.
That's exactly right, and I think that's one of the key issues. The news reports have said that these things, people can no longer do these things because the health insurance is not covering them. That's not true. All these things will still be available, worse luck, but all these things are no longer on the government coverage or government subsidy because there is no evidence at all that they work. Now, there are a number of other areas which they have allowed through which have similar problems with whether they work, and one of those is traditional Chinese medicine. But that's still covered, and yet there are many areas there, many areas there, which not only do they not work, they're also dangerous, as in all the rare animals that have been killed for traditional Chinese medicine.
That's Tim Mendham from Australian Skeptics. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.